last section here, we are going to do the hearing and equilibrium tests. They are the Weber's test and the Rhines test, both in the lab manual. We are going to skip the localization of sound. That was pretty easy. You just hit the tuning fork and you move the sound all around their head, and they close their eyes and they tell you where they hear it. Usually if there's no hearing loss, they can pick it up wherever it is. Also the audiometer, I didn't bring that, but basically you guys all did this probably in elementary school, listening with the earphones on, and you hear the beep. It comes at different levels and sound intensity, decibels, and different frequencies, and you just raise your hand when you hear the beep. We usually administer those in lab, but I'm not going to do that one. So the Weber's test, what we do for this one is we have a tuning fork right here, and there's a little bass, and you can like strike it, and it creates vibrations, sound. So we're going to place the tip of the handle in the middle of her skull or the forehead, and if hearing is normal, the subject's going to hear sound equally well on both ears, okay? And if there's some sort of hearing loss, they will report not being able to hear it as well in one ear or the other. So we'll do it first on the forehead with both ears open, and then have her put her finger in her ear and close the ear. And basically, these detect whether there is Weber's test determines whether there is normal or conduction hearing loss, or if there's a sensory neural hearing loss. Conduction hearing loss means there is either damage to the bones or fluid, or the conduction system going into the cochlea has some damage to it. Sensory neural means the hair cells or the neurons are actually damaged that bring that information to the brain. And so we can do is a way to figure that out by this. If she covers one of her ears and there is conduction hearing loss, the subject will hear the sound louder in the closed ear. Or if she has normal hearing, she'll hear it louder in the closed ear because it's going to conduct. She'll be able to hear it through kind of the bones of the skull through conduction. And if there's sensory neural hearing loss in the closed ear, the sound's going to be heard better in the open ear. So it's a way to differentiate conduction hearing loss from sensory neural loss if it's there. So I will hit the tuning fork and I'm going to put it on her forehead. See, it's yeah, both ears open first. So I kind of hear it. Can you hear it in both ears?
Yeah.
Okay, so she can hear it in both ears. So we're going to do it again. She's going to plug first the left ear and then the right ear.
Wait, do it on the table. It wasn't...
A little bit louder? Okay, we're supposed to strike it on sort of a soft surface, so I don't want to do it too hard. Okay, that's better. And she's closing her left ear.
I only hear it in the ear that's closed.
Okay, so she only hears it in the right ear that's closed. Perfect. And you want to cover the left ear? And we'll do it again.
I hear it in the ear that's closed.
Okay, so she only hears it in the ear that's closed. That's good. So it's conducting through the bones of the skull, through the temporal bone, and into the ear. And so through that conduction, it's activating those hair cells. So she doesn't have conduction hearing loss or sensory neural hearing loss, and she has normal hearing. Okay, so the Rhines test is the second test in picking up hearing deficits. Basically using the tuning fork to using bone conduction through the skull, and we're going to put it on the mastoid process, which is the little bony prominence right behind the ear. And then for doing this, we're going to listen to the tuning fork using air conduction. So we're going to first hold it against the back of her ear, and then when she no longer hears the sound, we're going to just hold it and move it so it's right near the external auditory canal. And so through air, basically through air conduction, she should be able to again hear the sound. So conduction hearing loss is indicated if the sound isn't heard by air conduction in this case. So we'll just do it right back behind the ear. We'll do it on that mastoid process. I'm going to hit. Could you hear it?
Yeah.
And then when it starts to go away, can you hear it if I just put it right near the opening of your ear, really loud? Okay, so we'll do it on the other ear. So we hit the tuning fork, put it right on the mastoid process, that little bony prominence right behind the ear. Can you hear it?
Mm-hmm.
Nice and good. Now if I do through air
Yes.
conduction, she can hear it really good. Okay, so for that, perfect. There is no conduction hearing loss. And so we just basically did both of those, the Weber's test and the Rhines test, and the results for that, she is normal. So Weber's test, normal, positive test result. Ryan's test, positive. She could hear all those. So no conduction and sensory neural or conduction hearing loss for doing those tests. Okay, so the last one is an equilibrium test. We're going to skip the audition results on the audiometer, which you would plot based on what they can hear in decibels and various frequencies. We'll go right and give you a demonstration of the equilibrium test. So this is kind of a funny one, and I even said here, like, the instructor must be present because students don't want to be flying all over the place and falling and stumbling. So this measures your vestibular sense or equilibrium and the effects that that has on the body and coordination and the eyeballs in focusing and keeping images straight on the back of the retina. So it's called the Barney chair test, but basically we're going to spin her around. So she's in a chair. You can even do this at home. It's kind of fun. You can do it to people. Just be careful where your setup is that the person doesn't fly off. Okay, so we got a swivel chair, and she can spin around. I'm going to have her close her eyes. She's going to look down, tilt her head about 30 degrees, because this way the semicircular canal, one of them, will be perfectly in line with the floor. So you have 3 semicircular canals in the vestibular apparatus, and they give you information on rotation. So rotational movement in different planes, or rotational acceleration. So with her head, your head rotated like this or pointed down 30 degrees, it puts it at a perfect location. Okay, so I'm going to spin her clockwise. Let's see, I'll get my little light pens ready to shine on her. So I have these little light pens that you guys have used, right, for looking at different reflexes, pupil reflexes. So I'm going to spin her 10 times clockwise. Oh, it's hard to do this in video at the same time. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do one more because I didn't do it very good. And then when I stop you, you are going to look straight ahead and we're going to look at her eyes. Do you see her eyes moving? See the pupils and the iris is moving? Okay, so basically her eyes were tracking. So once she stopped and her eyes were open, her eyes were tracking. So they were moving sort of that way to the left, and then jerking back to the right, and then moving to the left and jerking back to the right. And if you saw that jerky eye movements, those were called nystagmus. Basically, the equilibrium is sending that information to the brain. The vestibular apparatus is sending that information to the brain that she was spinning in that direction. And then the brain communicates to the eyeballs, the irises and the eyeballs to actually move the eyeballs back and forth so they can try to keep all the plane of vision fixated straight and steady on the back of the retina. So it causes the jerkiness of the eyeballs or nystagmus. So the eyes will kind of jerk back and forth. Okay, so the last one is to demonstrate your sort of how your coordination, how you're able to throw. And we're going to use a tennis ball, and we're going to do the same thing in spin. So you can do a test run just to see how good you are. Some people are really good at aiming, so she's pretty good. She got it. She was close. So her trajectory is kind of straightforward. It's pretty good. All right, she got it. Perfect. Our little garbage is not so great. Okay, so now we're going to do the same thing, and this is basically to show equilibrium and communication basically out to the limbs and proprioception and movement of body position after spinning is often altered. So you've probably seen people spinning on baseball bats and trying to run, and they run off to one direction. So that how off they are, or off shooting from the target, usually results from lots of spinning because of activation from the vestibular apparatus. So it's hard. The brain has a really hard time sort of getting the body to go in that direction. Okay. So we're going to try to do the same thing. Okay, so I'm going to spin you counterclockwise, head 30-degree angle, eyes shut, and we're going to spin you clockwise, not counterclockwise. I'm going clockwise. 2, 3, 4, 5, 6, 7, 8, 9, 10, and then steady, and then go ahead and throw. Okay, so you went off a little bit to the left. Okay, that makes sense. A little bit off to the left. And she normally has a really good throw, so that makes sense. So what we would just record right here, the equilibrium test. Basically, the results are right here. Rotation, direction of the subject. She went clockwise. That's the direction I spun her. And then the direction of slow drift of her eyes were kind of to the left. And then the direction of the abrupt return, so her eyes would go to the left slowly and then yank back to the right, and then go slowly to the left and then yank back to the right. So the abrupt return is typically to the right. And then the direction of the pass point, so the pass point, where was she kind of off and throwing, and it was to the left. And this is basically that information on rotational acceleration or rotation was being sent to the brain and then affecting what her eyes and her body were actually able to do after that. So that is the last test. The rest of those are just discussion questions. So that was most of the tests actually for vision, hearing, and equilibrium. Thank you so much for your help. Yeah. All right, hopefully this was at least a semi-helpful demo of the test and sort of the results and how to interpret them. I'll put that back down. We were going to do the hearing test on little TTR Kitty, but she ran away. I put the tuning fork on her head, and she didn't mind. Okay, see you all later. Bye.